Okay, Longhorns. Now what we're going to look at is on page 36, we have finding the average rate of change of a function from x1 to x2. So usually rate of change we've related to linear equations and not so much to any other kind of equation that has a curve. But now what we're going to learn how to do is find the average rate of change in a function between 2 points. And basically what they give us is two values for x that we're going to use. So we're going to use a specific domain to find the average rate of change between those 2 points. And that's basically all we're going to do. So what I'm going to do is I'm going to expand this picture here of what exactly it is we're going to be doing. Okay, so for this particular function, they've given us this point, which they've labeled x1 and f of x1, which is basically y. So they've given us an x and a y for this point, and they've given us an x and a y for the second point, and that's why we have x1, y1, x2, y2. And it's these 2 points that we're going to use to find this average rate of change here, or the slope of this line that we call the secant line. All right, so it's just like in the linear equation when you find the rise over the run. We're going to do the same thing with this equation and with this function, and we're going to use the slope formula. So if you remember the slope formula, which should be in your notes somewhere, the slope formula is y2 minus y1 over x2 minus x1. Okay, and that equals slope, and sometimes we use the letter m to represent slope. So you've got this information, and this is all we're going to do. So you should already be very, very familiar with this formula and how to find slope. Okay, so let's take a look at our first example. We're going to look at this example right here. I'm going to make it bigger so you can see it better. Okay, so basically what they've given us is they have given us a linear function. For example 1, it's 3x plus 8. Well, most of you know, if you know the formula y equals mx plus b, you know that slope is m, so the slope for this line is 3. Well, how do we know that slope is really 3? We're going to prove it using our rise over run, given these two values for x. Now, sometimes you'll see this written this way. There'll be a bracket, and then the first value for x, and then a comma, and then the second value for x, and then a closed bracket. This is called an interval. So between this interval and the domain, from 0 to 3, we want to know what is the slope. Well, we're going to start by creating a table of xy values. And we're going to use these two values that they've given us as our x values. These are our x values. This is a set of x. So I'm going to use these two x values. This one is my x1, which is 0, and my x2 is 3. And all I'm going to do with these values for x is I'm going to plug them into my equation. Well, this is pretty basic equation because this is just a linear equation. So I'm plugging 0 in for x. I get 3 times 0 is 0 plus 8. So 0 plus 8 is just 8. So I get a y value of 8. Now I'm going to plug in my 3. 3 times 3 is 9. And 9 plus 8 is 17. So my next value for y is 17. Now I'm going to use my slope formula to determine the slope of this line. So this is my x1, and this is my x2, and this is my y1, and this is my y2. So my formula for slope is y2 minus y1 divided by x2, which is 3, minus x1, 0. Now what I should get, believe it or not, is this 3 right here. What do we get when we do this calculation? You can do this calculation in your calculator, or you can do it in your head. This one's pretty basic. So when I do this calculation, I get 17 minus 8 is 9, divided by 3 minus 0, which is 3. And I know 9 divided by 3 equals 3. So my slope is 3. And that's basically all we're doing to find this average rate of change in these different functions. Let's take a look at our next example. This is example 2, and I'm going to leave it kind of big here. This is a cubic function, and they want us to use 1 for x1 and 6 for x2. Okay, so we create our table, and we're going to use 1 for x1 and 6 for x2. And so now what we need to do is we need to plug those values into x and solve for y. Well, when I plug in 1 here, and I plug in 1 here, and I plug in a 1 here, I get negative 1 plus 6, that's squared, plus 6, so negative 1 plus 6 is 5, plus 1 is 6. So here I get a 6. You can also do this in your calculator by entering your function into the graphing app on your calculator and go to the table, and you'll also get a list of points for your function. So when the function is, the value for x is at 6, we have a negative 6 cubed, which is going to give us a negative 216, and then when we substitute 6 in for x in 6x squared, we also get 216, so plus 216, and then we substitute 6 in for x at the end and we get plus 6. Well, these 216s just cancel out and we're left with 6. So when x is 6, y is 6. So we want to know what the average rate of change is for this function between the domain of 1 and 6. So we're going to use our slope formula, which is the change in y over the change in x. And in this case, we get a 0 over 5. Well, 0 divided by 5 is just 0. So if you can tell me what kind of slope that is, you get a special treat. Now, the next 3 pages, pages 37 through 39, we're going to do in class, and you're going to answer all of the questions that are on those pages. We can work them together, or we can work them independently. Whichever way we decide to do it, we'll try to make it fun. And if you have any other questions or need any help, you know we're always there for tutorials. Have a great day, Longhorns.